Hi guys, so let's solve some questions of lines, angles and triangles. Moving to the first question, how many different triangles having integral valued sides will have perimeter of 14? Now, this is a triangle. A, B and C are the sides of the triangles. So we have to make use of the properties. So first property is perimeter, that is sum of all the sides is equal to 14. Now, sum of any two sides is greater than the third side. This is a property of triangle. So if we have to take it in this way, I can say that I'll transfer C to the right. It will become 14 minus C. Hence I'll get the value of A plus B, that is 14 minus C. And now this minus C would be transferred to the right. C and C will get added and I'll be left with 2C less than 14. So the value of C will be less than 7. Now another important property is the longest side of a triangle will always be less than its semi-perimeter. So semi-perimeter is 7, so longest side will always be less than 7. So let us assume the values now. C is the longest side. C is has to be less than 7. So let us assume the value of C as 6. If the value of C is 6, then A plus B would be 8. So let's figure out the possibilities of A plus B as 8. So 6 2 is first possibility, and yes, it is satisfying. 5 3 is second possibility, and yes, it is also satisfying. 4 4 is another possibility, yes, it is satisfying. Now, these are the only triangles, only three triangles that can be formed by using 6. Because if you take any other value, that is 7. So if you take 7, it won't be possible for a triangle to be formed because in that case it will contradict the property as 6 is the longest side and it's of C, hence 7 is not possible. So let us take 5 now. Now by using 5, now we can say that A plus B will become 9 and 5 and 4 is the only possibility that we can form by using C as 5. So in all we can form 4 triangles. Option 2, 4 is the answer. Moving to the next question, how many triangles having integral valued sides will be an obtuse angle if the longest side is x and the other two sides are 5 and 7? Again, we'll make use of the property sum of two sides of a triangle is always greater than the third side. So 5 plus 7 is 12 and 12 is going to be greater than x. That means the value of x will definitely be less than 12. Also, in the previous question, we learned one property that semi-perimeter is more than the longest side. So, by using that property over here, but also we don't have the value of x. This means we can say that x has to be greater than 8. How? Because one of the sides is 7. And if x is the longest side, it has to be greater than 7, right? So x can take values from 8, 9, 10, and 11. So x is greater than 7 and it is less than 12. So these are the values that x can take. Now, by applying obtuse angle triangle property and acute angle triangle property, we'll easily get the answer. So we'll square the sides. That is going to give us the sum as 74. And these are the values of x squared. Now pick values of x square and compare that values with the sum that you have got. 64 and 74, which one is greater? 74 is greater. Hence, it's an acute angle triangle. 81, 100 and 121 are greater than 74. Hence, it's an obtuse. They are an obtuse angle triangle. So we can form one acute angle triangle and three obtuse angle triangles. Option 2, we can form three obtuse angle triangle is the answer. A ladder 85-meter long is resting against a wall with its bottom end 40 meters away from the wall. If this ladder slips 7 meters from the top, by how many meters will its bottom end move further away from the wall? Now the diagram of the wall will be in this way, and here's the ladder that is resting. It looks like a right angle triangle. So we'll obviously make use of Pythagoras theorem because it's a property of right angle triangle. Now h is not known, ladder is known, base is also known. By using Pythagoras triplets or Pythagoras formula, we can easily find the value of h. So h square is equal to 85 square minus 40 square, that is 5625. Square root of 5625 is 75, hence the height of the wall is 75. Now the ladder slips 7 meters from the top. So if it slips 7 meters from the top, obviously it will move away from the bottom part of the wall. It will move away by some meters. We don't know that, so let us assume the value as x for that. And we have to find the value of x only. In the question, they are asking us to find out the value of x. Now again, we'll make use of Pythagoras theorem only. But in this case, the height of the wall won't be 75 but 68 because the ladder has slipped by 7 meters. Hence, again by applying Pythagoras theorem, that is 40 plus x the whole square is equal to 85 square minus 68 square. After solving this, we'll get the value of x as 11. So 85 square minus 68 square is 2601 by taking square root. So square root of 2601 is 51. We'll get the equation that is 40 plus x is equal to 51. The value of x would be 11. So 11 is the answer. Moving to the next question. ABC is a right angle triangle at B. BD is the height on the side AC. Find length BD if AB is 3, BC is 4. Now, over here, we have these lengths, so we can easily find out AC. So AC is going to be 5 by using Pythagoras triplet. Now, over here, we can have two triangles. How come? See, so the first triangle is going to be A, B, C, and second triangle is going to be C, B, and A. Now, these two triangles are not at all different. I'm talking about the same triangle, but if you observe, when I say triangle ABC, the base for that becomes AC. And when I say triangle CBA, the base for that becomes BA. So why am I focusing on the base? Because if we apply area of triangles formula, we can easily find what we want. We can easily get what we want. So in some cases, you have to think in a different way. So these are two different triangles, but I'm talking only about one triangle. So just for my convenience, I've considered the base different. So as you can see, area of triangle ABC would be half into base into height. Base is AC, height is BD. And area of triangle CBA is equal to half into base into height. Base is BA, height is BC. So by putting the values in the formula, we can easily get the value of BD, that is 2.4. So 2.4, option 2 is the answer. Moving to the next question. In triangle PQR, S is the midpoint of QR, T is the midpoint of PQ, and U is the midpoint of QT. Find the ratio of area of triangle PQR upon area of triangle QUS. Now, in such type of questions, you can assume some values. So, now just focus on triangle ST and Q. SU is a median. It divides the triangle into two equal areas. So if I assume area of triangle SUQ as 1, area of triangle SUT will also become 1. Now, focus on the left one triangle. On the left one triangle. Left one means what? Focus on triangle SPQ. In triangle SPQ, ST is a median. Median divides a triangle into two equal areas. So, the two triangles would be STQ and STP. So if STQ is 2, STP is also going to be 2. Now, look at the bigger triangle, that is PQR. In triangle PQR, PS again is a median. Median divides the triangle into two equal areas. So the left triangle, that is PQS, the area is 4. So PSR, the area is also going to be 4. Hence, area of triangle PQR is 8 and area of triangle QUS is 1. So the ratio is 8 is to 1. Option 1 is the answer. Moving to the next question. In triangle ABC, AB 24 centimeter, AC is 12 centimeter, median AD is equal to 3 root 31, find BC. This is a triangle that we have. This is a median. Median divides the opposite side into two equal parts. By making use of Apollonius theorem, we can easily find what we want. So AB square plus AC square is equal to 2 into AD square plus DC square. By just putting in the values and solving, we'll get the value of DC as 9. If DC is 9, then BC is twice of DC. So 2 into 9, that is 18. So 18 is the answer. Moving to the next question. M is a point on side YZ of triangle XYZ such that YM is 1/3 of YZ and N is the midpoint of XZ. What fraction of the area of triangle XYZ is the area of triangle MNZ? So this is a triangle XYZ. We know that YM is 1/3 of YZ. So if YZ is 3, YM is going to be 1. Now, YN is a median on XZ. What do we have to find? We have to find area of triangle MNZ upon area of triangle XYZ. So MNZ, for that, we'll draw a line. And if we draw a line from that, it looks like MN becomes median of triangle MXZ. I repeat, MN becomes median of triangle MXZ. Now, if we know that XMZ is 2, that means the entire triangle, the entire area of triangle XMZ is 2. So we can divide 2 into 1 and 1. How? MN is a median. Median divides a triangle into two equal areas. So triangle MNZ will become 1 and triangle MNX will become 1. Now we can easily find out the answer. Triangle MNZ is 1, triangle XYZ is 3, hence 1 upon 3 is the answer. Moving to the next question. Triangle PQR is an equilateral triangle with side X. Point S is a point on side QR such that PS trisects QR. Then PS is equal to what? Now, it's an equilateral triangle with side X. PS trisects. Trisects means divide by 3. Now, PX is also height. Blue line is the height. Now, we can say that for in case of an equilateral triangle, height, median, all the lines are same. Hence, XR is x by 2 because Px is a median, the blue line is a median, and it divides the side into two equal parts. Hence, if it divides into two equal parts, if I say the value of QR is x, then XR is going to be x by 2, and remaining QX is also going to be x by 2. Now, in QX, we know that QS is x by 3. So if QS is x by 3, SX is going to be x by 6. You are simply going to subtract x by 2 minus x by 3. If you subtract x by 2 minus x by 3, you will get x by 6. And that is the value of the remaining part. The remaining part is Sx. So this is the remaining part. So I'll fill it up by doing x by 2 minus x by 3. That is going to give me s by x by 6. Now, we know that height of an equilateral triangle is square root of 3 by 2 into side. This also looks like a right angle triangle, isn't it? Now we have the height of right angle triangle, we have the base of right angle triangle. By using Pythagoras theorem, we can easily find PS square. So PS square is equal to 7x square upon 9. By taking the roots, we'll get root 7 by 3 into x. So option 1 is the answer to the 8th question. Moving to the 9th question. In triangle PQR, V is a centroid. If line ST parallel to QR cuts the triangle PQR at a height h by 4 from QR, find the distance VV1 in terms of PV if V1 is the centroid of triangle PST, height and median of triangle PQR is equal to h. Now, this is a triangle that we have. This is first point, that is centroid V, and this is the line ST. Now we know that it's 1/4 of the height, so it is going to be h by 4. Now, if the bottom part is h by 4, the upper part is going to be 3h by 4. That is the remaining part of h by 4. So the upper part is going to be 3h by 4. Now this is another point, another centroid, that is VI, that or V1. So now we can say that PV is equal to 2/3, 2 by 3 into h. So PVI will become 2 by 3rd into 3h by 4. So that becomes h by 2.